is Adam Skarke on the ship. We've just reached bottom with the ROV, and this hard bottom appears initially to look like an area of seepage. Cold seep is a location where we have fluid coming out of the seafloor. This can either be a gas, natural gas like methane, or it can be a fluid like groundwater or brines that come out of the seafloor. This looks here like we've got a very small brine pool. These are highly dense, highly saline waters. You have very high degree of dissolved salt in this water, and so it's much denser than the overlying seawater, and it seeks flow spots. And so you see pools, and sometimes we see rivers of moving brine. We can now see pretty clearly the shimmering created by the density contrast in the water of that fluid coming out of the seafloor. I think we're moving up an extinct, what could be a relic brine waterfall here.
So those mussels actually have symbionts, so they have bacteria that live within, and those bacteria can harvest the power from methanes and other gases and provide nutrition to the mussel. So these are a really important foundation of the species for these chemosynthetic environments.
The Okeanos Explorer was one of the first ships to find a widespread methane gas seep along the Atlantic margin of the U.S. East Coast. We were keeping an eye out, seeing if we could find such plumes in the water column, and those were discovered in 2012 right off Virginia. We saw our major gas seep, and then within that cruise we saw a couple more seeps farther north. With that impetus, we went back through and looked at the many years of collected sonar data from the Okeanos Explorer. We ended up finding almost 700 sites of individual gas seepage.
We can see if there's bubbles in the water column or sonar anomalies within the water column of the sonar itself, and they can also be used to find seeps.
A lot of these chemosynthetic environments, you have a lot of abundance. So a lot of the deep sea floor is flat and not like a lot of life. But when you find these seeps, you see an incredible abundance, and that's exactly what we're seeing. Those are chemosynthetic tube worms. So those tube worms actually don't have guts anymore. They get all their nutrition by bacteria that live inside them and that use the energy they get from gases.
Something that's quite remarkable is chemosynthetic communities, and this concept of chemosynthesis is relatively new. It was only in the 1970s that we discovered in the deep sea the first organisms that were chemosynthetic. So before that, it was presumed all life was photosynthetic. That was plants using chlorophyll to transfer sunlight into energy, and that being the basis of all food chains. It's only been within the past 50 years or so that we've understood that there are different organisms, particularly bacteria, that can synthesize these chemicals in the deep sea in the complete absence of any sunlight, and that can serve as the basis of food chain for entire communities like we see here. The large carbonate rocks take quite a while to grow to the size that they are. Those indicate that in many locations we've had persistent seepage over many thousands of years, some dated back as far as 15,000 years in the Atlantic Ocean.
It has been a truly spectacular dive today.
Days like these, you can't believe you get paid to do this sort of thing.